Good day. This is Gary from G&H Honeybees, and it's December 18th, 2020. And it's about 7 degrees Celsius, or about 45 Fahrenheit. And because it's cold, rainy, and the bees are all curled up and huddled up, sleeping for the winter, by the looks of it, I've decided to do some inside projects. And what I've got here is just an electric chainsaw, and if you see here, there's a chain oil tank, and the original cap, which is the one on the left here, just split on me. I can get that under the camera. You can see it just broke, and that's because the outside of this is so thin that it just gave out. So I thought I'd sit down and design a new 3D printed cap, and this little rubber bulb just fits into the center of it. That would sit in there so you could pump some oil. So I sat down and designed this new cap. I've made the outside of it here a lot thicker so it shouldn't break again, and the rubber pump part just fits into the top of that. And I don't know if the camera is going to show it up. It's not too, the lighting's not too good here. But you can see that the bottom of that cap is sealed against the inner lip. And I'm going to follow this up by showing you a how-to video in Freecad and how I did this. And this is how the new cap fits on here. Alright, nice and tight, seals it up, and pump oil out of it. You can see it's got some knurling around the outside of it so that you can get a grip on it. And it kind of looks like the original cap, except it's a little fatter and bigger. So that's one of the things I've been doing. So now that I've shown you that part of it and that it fits on there nicely, I will now proceed to show you the Freecad video and how I did it. Alright, so be back in a minute. Okay, so here I am on my PC, and we're going to use Freecad version 0.18. And we're going to start a new model. I'm going to create a body. I'm going to create a sketch. I'm going to go on the XY plane base. And here we have a drawing. So I want to create a circle in the middle here. We'll just grab the center of the circle, the center of the axis, and center that circle. Now I've determined that the outside of the original cap was like 24 millimeters, which made the outside skin of the original cap way too thin, and that's why it cracked. So I'm going to make this 30 millimeters, and because of the way Freecad operates, if you're doing this radius, you only put it in half. So 15 millimeters will create a 30 millimeter circle. So I'm going to close that. I'm going to use the pad function, and I measured the cap depth, and it's 12 millimeters, so I'm going to set that to 12. And now I want to create a new sketch, and I want to create another circle. And again, I want to click the center of the circle, center of the axis, and I want to constrain that circle to the center. Now this circle is going to be the opening for the rubber pump button, and it is 18 millimeters. So I'm going to make this 9. We'll click close, and now we want to pocket that 2 millimeters deep. Click OK. So now we have this pocket in the middle, and this is where the rubber pump button will fit into when I'm finished. Next thing I want to do is I want to create some knurling on the outside. So I'm going to take the multi-line tool. I'm going to create 3 lines, which will be a triangle. And I click the 2 open endpoints. I want to join them together. Next, I want to center the top part of that with the axis. So I click the symmetry constraint button, and that makes these dots the equal distance from the center. And I want to make this 1 millimeter wide. So I click those 2 outside points, and I click the length, and I want to make that 1. And I've been sort of studying Freecad a bit, and I'm finding out that I'm not using anywhere near the full potential of this program. So there's an easy way to make this triangle symmetrical. So you click the top bar, hold down the control key, and click the other 2 lines, and simply press the E key. And that makes an equal triangle there. And next, I want to set the distance from the center axis, the vertical distance. And let's make this 14.2. Now, I'm going to pull this down. I want the top of this to be outside of the circle so that it creates a V profile in the outside rim of the outside of this pad. So now that that's fully constrained, we click close. We're going to pocket that, and we're going to make that 10 millimeters deep. Oh, get back here. So now you see I have a V groove here. So in order to make the knurling on the outside, I want to click the polar pattern feature. I want to click the pocket that I just created and click OK. And now you see it, the occurrences is set at 2. So now you see there's a groove there and a groove at the top, but we want them all the way around. So I'm going to make 60. And this will take a minute. There we go. Now, I know it looks like it's got flat tops here, but because the measurements are so small, it'll look pointed when it's all printed out. So that's the top of the cap. So now we get into the more complicated part of, click OK over here. Now we want to get into creating a thread profile on the inside of this cap. So we switch from part design to thread profile. And you click the top. Make sure you only click the top of or the bottom, as it would be, of this pad. And we want to select this first, create a standard V-thread profile object. So you click that. And now you see a circle shows up there. So let's go back to the model and the combo view. And there's a V-thread profile. So I did some other measuring. I know the original cap is not perfectly round and it's broken. So I've done the best I can to figure out dimensions for this. And roughly the tops of the threads on the inside are 22 millimeters apart from side to side. So I'm going to enter 22 millimeters in there. And the pitch is about 4.2. And the thread count is about 2.5. Now, that looks a bit weird as it sits, but I'll make this a little more clear in a minute here. So now that I've got the V-thread profile set up, you'll see that this next button here, make a part helix object. and set its pitch to match. So when I click this, it creates this shape binder object and then this helix. Now if I spin this over, you can just see in the center there, this little yellow object sticking through here. That's the bottom of the helix, and that's about all I want sticking through there. Now, the other thing I'm going to do so you can see what's happening, I'm going to click this, and I'm going to press the space bar, and that's going to make the outside object go away. Not go away, but make it invisible. So this flat disc at the top is the V-thread profile, and then you'll see I have a helix here that the thread pattern is going to follow when I do the next operation. So if you click the V-thread profile and then hold down the control key and press the helix, you'll see now that this button is lit up and it's sweep a selected thread profile along a selected helix or shape binder. So we just click that and voila, there's the threads. Now you're wondering, I got that. How am I going to let's bring this all back, set visibility and space. There we go. Turned it all off. Why did not turn back on? All right, let's do this one at a time. Toggle visibility, toggle visibility. There. So there's our cap with the thread profile on the inside of it in the center here. So you might be wondering how now I'm going to actually make the thread, the inside thread. So I want to switch here from thread profile to part. And then I want to click on the body, and then I want to hold down the control key, click on the sweep. And you'll see this lights up and it's make it cut of two shapes. So I click that. And we wait. I'm still waiting. My PC is not what you would call current, so it's a bit slower at doing some of these functions. And there you go. So now you can see on the inside of this, there's a thread. And you can also see down here in the bottom of this that there's a lip. Now that rubber cap that fits in there has a portion of, it has a lip on it itself that will seal against this and the top of the oil tank opening. And when I print this out, I want to print it so it's laying like this on the print bed. If I printed it so it was laying like this on the print bed, the printer software would want to build support structure like a scaffolding on the inside of this thread so that it could properly print this flat surface here on the inside. So in order to get around that, I want to print it so that it's actually facing this way on the print bed. And that way it doesn't have to do that. It can just print this lip without um, having any support structure required. And then the printer will continue to move its way up and up and up and up until it's finished. So I've already uh, saved this and everything, but the last step here is to go to Mesh Design, and then we want to create a mesh from the shape, and we want to highlight all of that stuff. Click Standard, click OK, and now we have um, a mesh that I can export out to. You just click the Export Mesh. I usually select the bottom part, the bottom mesh here, because it will contain everything else most of the time. So you just right click on that, and then you click Export, and then you can save the mesh out as a file that you can then convert to 3D printing code. So let me minimize this, minimize that. We'll start up this other program. And we want to open recent. We'll just open that. I'll zoom in on that. Now there's the profile of that cap, but as you see, it's decided that it wants to print it from the bottom of the cap up to the top, which is not what I want. So I click on that, and over here I click on the rotate function, and I simply turn that over. And now it'll print from the top portion of the cap to the bottom. And that way it doesn't need any supports on the inside of it. And it'll be a nice clean print. And then all I do after this, you can see it's going down here in the bottom. It's going to take 46 minutes to print this cap. All I do is I put my SD card from my printer into the PC, and then I can save this profile directly to the memory card, and then I put the memory card back in the printer, and then I can select that profile and it'll print out. And as you've seen, the resulting cap, it looks pretty good, fits well, and it will do its job. And because I made the outside circumference here a lot thicker, it shouldn't break. And because I'm using PLA plastic to print this part in, PLA is virtually impervious to oil and gas and acids and pretty much everything else. So it should stay good for a long time. And now that I have the design done on my PC, should the cap that I printed break for any reason, I can simply print out another one. I don't have to worry about trying to find another cap. So that's it in a nutshell, and hope you enjoyed the video. I hope you're all staying safe and happy. And because it's a little more than a week from Christmas, I'm going to now wish you all a very Merry Christmas and a Happy New Year, because I don't know if I'll have any other videos out between now and then, but you never know. So that's it for now. Hope you even, like I said, I hope you enjoyed the video. So we'll talk to you again soon. Thanks for watching. Bye for now.